The three forms for the parabola. Two of them we discussed before we left for the holidays. One of them was introduced. Vertex form, standard form, and intercept form. And what did I say another word for intercept is factor. So today is going to be simple. We're going to, if you understand factoring, it's going to be simple. If you don't understand factoring, you're going to struggle. But we're going to go from standard form to intercept form. How do you recognize that any polynomial is in standard form? No parentheses. Okay, and then the polynomial is arranged from biggest exponent to least. In this case, since these are all quadratics, the biggest exponent is going to be a 2. But if you look through the worksheet I gave you, it's all going from biggest exponent to least. So all we need to do then is just factor. That's all we have to know how to do is factor. Okay. Let's actually do this. Let me skip to number 2 because I'm looking at number 1. It's going to be a little more challenging. I don't want to confuse you right off the bat and then lose you after that. So let's go to number 1. Let's go to number 2. How many terms do you see there? 3. Okay, and we should have learned before to identify A, B, and C when we're in standard form. What's A here? 1. What's B here? 17. And what's C? Now, okay, listen. If you were not with me the first half, your teacher might have taught you something slightly different. Like, it's the same thing. It's the same thing. It just looks different. The graphic organizer that they use is a little bit different, where they do this thing with an X. If you understand how to do that, and cool, like I have no problem with it. I honestly don't completely understand. Like, I get how it works. I don't see how it helps or how it makes any life any easier. So I'm gonna do it the way I've done it. It's just arranged slightly different graphically. So here's the way I teach it. I teach a 2-column method, which is there's 2 columns. At the top of the first column, you're going to write whatever A times C is. If A is 1 and C is 70, what is A times C? I'm not recording this. Wait, sorry. Is this recording? Oh, it is recording. All right. 1 times 70 is 7. On the top of the second column just goes B. So the first column is A and C. The second column is just B. What's B? 17. 17. The first column is a multiplication column. The second column is an addition column. We always start with the first column, and this is what factoring is. This is the reason why people struggle with factoring, because they don't know the times tables. Okay. On the first column, you need to think of any combination of numbers that you could think of to multiply to 70. You don't have to list all of them. All we're trying to do is figure out one pair of numbers that when I multiply them, give me 70, and when I add them, give me 17. Look, I know off the top of my head, I know it's going to be 7 and 10. I don't have to do this big investigation to figure out what they are. I know it's going to be 7 and 10. But it's not always that evident. It doesn't always just come that clearly. So, you know, if I were to show you the whole progression, what you would do is on this side, you would think of, okay, what are all the numbers I can multiply to give me 70? 1 and 70. 2 and 35. 4 doesn't work, 3 doesn't work, 5 works. 5 works 16 times. And then 7 and 10. Those are all the combinations of numbers that when I multiply give me 70. Now you just have to see which one of those also happens to add up to 17. If I add all of these up, this gives me 71, 37, 21, 17. Obviously, which one added up to 17 is 7 and 10. Huh? Did I do wrong, man? Yeah, it would be 5 and 14. Thank you. You did that in your head or you had a calculator? Huh? Okay, sorry about that. Another thing, if you're going to do it this way, we could try to take advantage of signs in order to help us get the correct combination, the correct pair. So I give my students, if you were with me last time, I gave my students like a little cheat sheet that said, all right, AC and B. And then it said the factors. So feel free to write this down, free of charge. If you have two columns, right, the signs can only be arranged 4 different ways. You can have them both be positive. You can have a positive and a negative. You can have a negative and a positive and a negative and a negative. That's what I'm talking about there is these numbers at the top. That's the only way it could be. So when I multiply two numbers and get a positive, what's the only, well, there's two ways that can occur. What are the two different ways you can multiply two numbers and end up with a positive? If AC is a multiplication column, how can I multiply two numbers and get a positive? Positive, positive, and negative, negative. So if my only two options are positive, positive, or negative, negative, but I know that at the same time I have to add up and get a positive, which one, there can only be one. Have you ever seen two negatives add up to a positive? I haven't. So this one would have to be both positive. Which would mean that if I have a positive multiplication but a negative addition, those would have to be both negative. For the last two, if I multiply two numbers and get a negative, what's the only way I can multiply two numbers and get a negative? No, what's the only ways I can multiply a number and get a negative? One positive, one negative, different signs. So in these scenarios, I have to have one positive and one be negative. But then, Martha, if I take into consideration the addition component of it, if when I multiply and get a negative, one has to be positive and one has to be negative, but when I add those two numbers, I get a positive, what else do I know has to be true about those numbers? I have one positive number and one negative number. Because when I multiply them, I get a negative. But if I know that when I add them, I have to get a positive, the smaller one has to be the negative, the bigger one has to be the positive. So this would be small negative, big positive, which would mean under the last scenario, the bigger number would be negative, the smaller number would be positive. Really fun? Yeah. Oh man, but that's too much thinking. I don't want to think that much. If you understand it, there's not too much thinking involved. It might just seem a little weird to you the first time, but here, look, let's apply that one to the one that we just did. On the top of the first column, the 70, was it positive or negative? Positive. On the top of the second column, the 17, was it positive or negative? Positive. So when I have both positives, what are my factors? Both positive. So all of these numbers had to have been positive. And then, of course, which one added up to 17? So the 7 and the 10. Before we go back to number one, I'm holding. Oh, actually, wait. I'm sorry. I'm not even done with this one. Sorry. Okay. Now, so the last thing you learned when you factor is you should go back and look at A. If A is 1, now you can just go straight to factored form. What was my variable here? What was my input variable? The x's. So if I were to rewrite this function, it would be f of x is equal to x plus 7 times x plus 10. That is this same function, but now written in what we call intercept form. Just factor. How could this be used to graph? Because functions get graphed. We're not going to graph today, but if you wanted to graph, how could you use this information to help you? This reveals the x-intercepts. When they call it intercept form, the reason why they call it intercept form is that tells you where we're going to cross the x-axis. If you were to make each one of these factors equal to 0, what you solve for would be the x-intercepts. Can somebody just look at this and in their head tell me where we're going to cross the x-axis? -7 and -10. If you make x plus 7 equals 0, you get negative 7. If you make x plus 10 equal to 0, you get negative 10. That's where you would cross on the x-axis if you were graphing. Would that be an up or down facing parabola? She has these such, I feel so bad. He has these confusion faces where you look like, if you're confused about something, just ask. This is where we would cross the x-axis. If I were to draw a graph, if I say x plus 7 equals 0, and I solve, I get x is negative 7. If I say x plus 10 is equal to 0, and I solve, I get x is negative 10. So I know that this would cross the x-axis like somewhere here, like wherever negative 10 is, and then like somewhere here, wherever negative 7 is. My next question was, is this going to be an up or down facing parabola? How do you know it's going to face up? Because A is positive. What's the only thing that we don't know about this parabola? Yeah, we don't know. Another thing we actually do know, we know where this is going to cross the y-axis too. Where is that going to cross the y-axis? At 70. Way up here, but it will cross somewhere up here at 70 because that's what C is. C is the y-intercept. The only thing we don't know is the vertex. If you were with me last semester, though, I showed you how to find the vertex, and that's actually what we're going to do tomorrow also. So like this parabola, a quick rough sketch of it would be that it looks something like that. All right, let me give myself some space here. We'll go back to number 1 after this one. Let's do number 3 next. The nice thing about number 3, even if you don't realize it, the reason why I'm doing this one next is because again, A is 1. It makes factoring a lot easier, but it makes it quicker. If you feel comfortable factoring with the x, I have some kids that swear to me that that is a superior method. I know how to factor by drawing an x on the paper. Fine, that's cool. I don't have a problem with it. Nobody's been able to convince me that it somehow aids you in any way. Like it doesn't. A times C is negative 30. B is 7. So now I'm looking for two numbers that multiply to give me negative 30 and add up to 7. I can do it in my head. I know it's going to be positive 10 and negative 3. I don't need any special help, but not all of you do. Not all of you can do that in your head. So at least using this method gives you a guide if you're stuck. By taking into account the little table I gave you, which reveals the signs to you, now I just have to think, okay, what's every combination, forget about the negative, what is every combination of numbers that I can think of that multiply to give me 30? Oh, that's 1 and 30, 2 and 15, 3 and 10, 5 and 6. Well, mister, do I have to write all that? No, you don't. You don't. Again, I just showed you, I can do it in my head, and it takes me like half a second to do it in my head. It doesn't take me very long. But and some of you can do it in your head, that's fine also. But if you can't, this way helps you. Now let's use that sign thing. Under this current configuration, when the first column is negative and the second column is positive, what did I tell you has to be true about your factors? Come on, did anybody actually write it down other than Caleb? Small negative, big positive. So go make all of the smaller numbers negative and make the bigger numbers positive. Which one adds up to 7? Negative 3 and 10, the one I told you was going to. So how would I write this in intercept form? I write f of x again. I would write equals, and now just write x minus 3 and x plus 10. Hyun, if I were to ask you, where is this going to cross the x-axis if I were to graph it? Where is it going to cross the x-axis? Is it because you don't understand? Do you think she understands what I'm asking her? No? Can you translate for me? X-axis. Very good. Yeah, positive 3, negative 10. Good. Thank you, Anne. You're going to have to be my translator. Very good. Where is it if we're not graphing, but just for fun, so you can show me you've learned something? Where would this be crossing the y-axis? Anybody can answer this. Where would this cross the y-axis? Negative 30, good. And then where would the parabola be facing? Up. The only thing we don't know is the vertex. We can find the vertex. If you were with me last semester, you should know how to find the vertex, even if you don't remember right now. But that's what we're going to do tomorrow. And then Friday will be a practice day for homework. Your first quiz is next week. I think it's on Thursday, if I remember correctly. Or is it even a quiz or a test? Look at the calendar. I get it confused. Let me see what you guys have. No, it's a test. It's a test already next Thursday. All right, so now let's go back to this dreaded number 1 that we've been avoiding, right? The reason why I avoided it is because what's different? Yeah, A is negative. The lead is negative. So having a negative lead does not mix well with any factoring method. Whether you're drawing an X on the paper, whether you're doing a column, no matter what it is, you don't want to have a negative lead. But luckily we have a fix for that. I just wanted to make sure you understand how to do it when it was positive. So what we can do now is take this function and factor out the negative. When you're factoring a number out using greatest common factor, it's like dividing. What happens if you divide any number by negative 1? The sign changes. So that's what we're going to do here. We're going to change this to positive, change this to positive, and change this to positive. So now what's going to happen is that negative is just going to stay out in front. And you've seen it before. You've seen negative A. Like, hey, if I ask you right now, where is that parabola going to face? What would you say? Down. Yeah, you just have the negative out in front, which causes the parabola to go down. But now when we identify A, B, and C by factoring out, now I can say A is positive 1, but then I have to say that B is positive 4, and that C is positive 3. Can you think of 2 numbers that multiply to give you 3 and add up to 4? There's only one possibility. Positive 1 and positive 3. That gives me what I wanted. Kiara, did that give you what you wanted? So that negative we knew was going to stay in front. And because A became 1, if you look ahead towards number 4, that's not going to really be the case. Well, it actually will be the case, but at least not at the beginning it won't be. Whenever A is 1, I can go straight to factored form. My 2 factors were positive 1 and positive 3, so x plus 1 and x plus 3. That is intercept form. Marquise, if I ask you where is this going to cross the x-axis, what would you say? Fantastic. Negative 1 and negative 3. The difference is it will be facing down. Where would this touch? Well, this is a good question. Where would this touch the y-axis? Yeah, because remember, if you're going to use C for the y-axis, it can't be after you factor. It has to be when it was in standard form. So back when it was in standard form with no parentheses, yeah, the C was negative 3. That's actually where it would touch the y-axis. So if I were to draw like a quick sketch of the graph, okay, it's touching down here at negative 3. It's crossing the x at negative 1 and negative 3. So this would be something like that. Like the vertex, if we were to find it, would be there somewhere in the second quadrant. Any questions? All right. Let's go to number 4. It's a little bit different here. Yeah, A is not 1 again. Okay, we have another one, A, but A is 2. In some cases, you would be stuck with, like, if I were to, like, okay, how can I say this? As far as standard form goes, A is 2, B is negative 28, and C is 96. So the fact that A is 2, now that we learned about transformations, what direction is this parabola going to face? It's still going to face up, and then what other transformation do we know has occurred? Based on what we learned on, what was it? A vertical stretch. This is going to be a vertical stretch. But that's not going to really help us with what we're trying to say, which is the factor. If you were trying to figure out where this is going to cross the x-axis, you know, that 2 isn't necessarily as important. So I need to factor, and as far as doing this is concerned, whether you're going to do an x or you're going to do that, as long as it's not negative, I could go straight into this now. I can identify A, B, and C the way I had it and go into it. But you might not have to. And in this case, I don't have to. The same way I brought out a common factor before with a negative, I can do the same thing with a 2 if it happens to be common. Do all 3 of those terms have a common factor? Yes. Yeah, so I'm going to do myself the favor and I'm going to bring it out because at the very least, what it's going to do is make the number smaller. And I'd rather do a table with smaller numbers than with bigger numbers. So I'm going to factor out a 2 and say f of x is equal to 2, x squared minus 14x plus 48. The kind of multiplication guy, is that right? 48. Okay. Now, the same way the negative stayed in front before, the 2 is going to stay in front. The 2 is not going to do anything else, it's just going to stay in front. So for the purposes of factoring, even though it's not the same thing as with the graph, it's nothing to do with transformations. But like if I were to ask you, where is this going to cross the y-axis? What would you tell me? It's not 96. It's going to cross the y-axis way up at 96. But for the purpose of factoring, we're going to say that my A is 1, my B is negative 14, and my C is 48. 1 times 48 is 48. Is negative 14. What we are looking for are 2 numbers that multiply to give me 48 and add up to negative 14. I know in my head it's going to be negative 6 and negative 8. Didn't take me that long. And I say it as me, but I'm sure there's some of you here that can do that without, like Brandon probably already has it on his paper. But let's say you don't, but I can't think of it. Okay, well, at least this gives you a process. That's my problem with the X method. I don't see a process. The only process I see with the X method all happens in between your ears, or your head. And some of you guys can't do this in your head. So if you couldn't figure out what the numbers are, you needed some method. You needed to do this methodically. All right, what number multiplied to give me 48? 1 and 48. And you need a calculator for this. 48 divided by 1, 48 divided by 2, 48 divided by 3, 48 divided by 4, 48 divided by 5. You know, and then those are the only ones you would have found. Each one of those combinations multiplies to give you 48. But then if you pay attention to the sign chart that I gave you, when my first column is positive and my second column is negative, what should I do to all those factors? Make them all negative. It has to be. They have to all be negative. So then which one adds up to negative 14? The one that I told you. Negative 6 and negative 8. Even though A did not start off as 1, because A ended up as 1, I can now go straight to factored form. But you just can't forget that the f of x, after the f of x came a 2. That needs to stay in front. And then x minus 6 and x minus 8. So Jada, Anne already told you that we're going to cross the y-axis at 96. Where would we cross the x-axis here if we wanted to graph? Where would this function cross the x-axis? Gary, you want to help her out? Not a -6. +6. And then what? Where else? Martha. +6 then? Let's see who knows how to fact. My brain is not what it used to be, but I'm almost certain that we talked about this in one of our first lessons. Okay, we want to go to intercept form here, which means we need to factor. But now, for the first time, we're factoring two terms. There is no common factor there that can be factored out. But who recognizes it other than Anne and Marquise? What do you recognize there? Close. What do we call it? Nakai, you know? Did I hear you mumbling it? What's it called? Good. Take that, Marquise. Good. Difference of squares. If you have two terms, but there's a difference, if you're subtracting and they're both perfect squares, that is a difference of squares, and it can be factored, which is what we're trying to do. You can factor by a shortcut. Who remembers what we call the factors of a difference of squares? Conjugates. X plus 7, x minus 7. Wait, but I don't get it, Mr. Romero. How'd you get that? It's just a shortcut. It's just memorizing the shortcut. I hope your last teachers taught you that. Ingrid, have you seen conjugates before? Okay, here's the only other way I know how to explain it. Okay, if I were to rewrite this, what does the word difference mean in math? Subtract, right? Okay. If I am subtracting two perfect squares, like what times itself gives you x squared? What times itself gives you 49? So if you have a difference of two perfect squares, you can take the numbers that you're squaring and arrange them as what are called conjugates. Conjugates is just get those two little bubbles and one time add them and one time subtract them. And the way that you know that this works is if you were to FOIL this, you would end up with what you started. The difference is this is factored, and in graphing, how would factoring help me? It would tell me where I would cross the x-axis. Later on, if you reach Algebra 2, they'll call those the roots of the function. Sometimes they call them the zeros of the function also. The zeros are the roots. So like Ingrid, where would that touch the x-axis if I were to graph that? Shelby, do you know? Very good, yeah. We would touch at, if this was equal to 0, that'd be -7. This would be at +7. Where would I touch the y-axis? B money, where would that touch the y-axis? Now that's 0. Caleb? Good, at negative, way down at -49, and would I be facing up or down? Up, yeah. Yeah, and because there's no b term there, the b is 0, that -49 would not only be the y-intercept, it would also be the vertex. Facts. Hey, the next one's a quick one. You should be able to do that one on your own. Give me that one in factor form, in intercept form. Quick, because A is 1, and you already finished, didn't you? How do you like the new website, man? Is it okay compared to Khan Academy? The Delta Math thing, is it harder to use? Is it okay? Somebody had recommended it to me last term, but I didn't really have time to incorporate it, but I just want to see how it works. So Give me some feedback because I've never really used it. You got it, Jason, right? You need an eraser. Don't got one, man. Sorry. It's okay. You're not gonna turn this in, so you can just scratch it off or whatever. Anybody other than Ann have the answer? What'd you get, Martha? 5. Yeah. Yeah. Good. Should have got an f of x is equal to x plus 2 and x plus 5. Oh, wait, Mr. Romero. I put x plus 5 and then x plus 2. Is that okay? Yeah, that's fine. You just can't put minus 2 or minus 5. But wait, I don't know how you got that. Well, if A is 1, B is 7, and C is 10, what two numbers multiply to give you 10 but add up to 7? 2 and 5. Do you have to show a table? No, you don't have to. As a matter of fact, I'd even take it a step further and say that by the time you reach the Algebra 2, anytime A is 1, you kind of expect it to be able to do that in your head. You shouldn't have to use any type of an X or a table or anything. When A is greater than 1, which we haven't done one of those yet, but yeah, maybe. But let's go to the second page. Oh wow, these are all pretty simple. Common factor. Yeah. Oh wow. And these should be pretty quick. Do number 7 on your own. See if you can come up with that one on your own and raise your hand when you got it. Sam, you got it? The first one? Almost. You got it, K Money? Still no, Sam? What'd you get? Now, well, see, the problem here is this guy. That negative 1 out of the front. Yeah, it means the parabola is going to face down, but as far as going into intercept form, it doesn't do well with factoring. Factoring and negative things don't mix well. So we would have to factor that out first. We bring out the negative, which makes the x squared positive, which is what we want. And then 2x will become negative, and 48 will become negative. So that now when we do ABC, A is 1, B is negative 2, and then C is negative 48. And then whether you did the x, or whether you did a table, what two numbers multiply to give you negative 48 and add up to negative 2? Negative 8 and positive 6. So, do you want to see me do the table? Does anybody want to see me do it? Have we done enough of that already? So, x minus 8 and x plus 6. what you had before? The signs were wrong, yeah. So Sam, if I were to graph that, where is it going to cross the x-axis? Good. Positive 8, negative 6. We already said it's going to be facing down. We're going to touch the y-axis at positive 48. Stretch. How was Martha's eraser? She's known for her erasers. People are on the school. Like, hey, Martha, you got any erasers? And she's like, yeah, here you go. Okay, the next one should take about 7.5 seconds. That can be done entirely in your head very, very quickly because A is 1. Yeah, I figured you did. Ingrid, did you get that one? Number 8. What'd you get? Yeah, x plus 2 and x plus 4. That one works out nicely because in front we have a positive 1, and then everything's positive. All the numbers are positive. A, B, and C are all positive. So even if we struggle a little bit with our times tables, we tend to be better when we're dealing with positive numbers as opposed to negatives. Jada, is that you have a worried face? You got that one? So then, Jada, if I were to ask you where is that going to cross the x-axis, what would you say? Not a 2 and 4. Number 8. Where is that going to cross the x-axis? Go, Jay. Well, at negative 2 and at negative 4. Because if you were to make Jada, if you were to make each of these equal to 0, you would get negative 2 and you would get negative 4. That's where it would cross the x-axis. Jada, where would it cross the y-axis? You forgot. You knew it one time, but you forgot. Is it Marmy or Marnie? Marmy, where is that going to touch the x-axis? Sorry, the y-axis at 8. And then the only thing we don't know is the vertex. But if you were with me last term, we went over it. I don't know if the other teachers did, and then we're all going to go over it tomorrow like one big happy family. So that's cool. Okay, notice how starting with number 9, when they just changed the notation. Instead of function notation, if they write y equals, so not so much that it would be right or wrong, but let's just stick to the way that they write it. So we're going to stick to y equals. The good news there is that y is 1. A is 1. So can you think of two numbers off the top of the dome that multiplies to give you 54 and adds up to negative 15? Yeah, negative 3, negative 18 is negative 21. Yeah. Let's do, but since there was a little bit of confusion, you know what? Let's take this chance to do a table, because this it looks like Caleb's bigger mistake was with signs. So luckily A is 1. So if we're looking for two numbers that multiply to give me 54 and add up to negative 15, well, the 54 part he probably did right. So 227, 3 and 18, 4 no, 5 no, 6 yes, and 9, is that it? So I see you got the 3 and the 18, but then this is where the sign thing helps. When I have a positive and a negative, what I told you that you wrote down is everything has to be negative. And negative 3 minus 18 is not negative 15, that's actually negative 21. It is negative 55, negative 29, negative 21, negative 15. The one that gives me what I wanted was negative 6 and negative 9. So I'll just write y equals x minus 6 and x minus 9. So that Jada, if I ask you, hey, where am I going to cross the x-axis, what would you say? Good. For sure. And if I ask you where that's going to cross the y-axis, what would you say? No. Come on, go back to what we did before the break. Standard form. Where do you find the y-intercept? It starts with a S and ends with an E. $54, yeah. And then Jada, is that going to open up or down? Uh-oh, what do we see again on number 10? There's a negative lead. So what do we got to do there for the negative? Factor it out. So before I start identifying, the negative means I'm going to open down. If I were to graph it, I'd be opening down. But Jada, look, I can look at this already. Where am I going to cross the y-axis? On number 10, yeah, the y-axis. At negative 30, yeah, like that's not going to change. I'm going to cross the y-axis at negative 30. I'm facing down. But if I want to write this in intercept form, which is like factor form, I have to factor out the negative 1, making this x squared negative 11x and then positive 30. Brian, can you think of two numbers that multiply to give you positive 30 and add up to negative 11? Yeah. Whoa, Mr. Romero, I wrote x minus 6 and then I wrote x minus 5. Well, that's fine. As long as you're not wearing a hoodie or you have a phone out or anything like that, then that's fine. Sam, where's that going to cross the x-axis? Okay. We'll do 11 together, and then you do 12, and then we'll be done. For 11, if I were to go straight and do a factor chart and try to factor now, it would actually work. I should be able to find the combination, but I'm going to be working with really big numbers when I really don't have to, because if I recognize that all three of these terms have a common factor and I factor it out, it makes life easier. If I factor out a 2, that leaves me with x squared minus 6x minus 18. So now I just have to think of two numbers that multiply to give me negative 18 and add up to negative 3. Negative 6 and positive 3. So y equals 2, x minus 6, x plus 3. Jada. Where is it going to cross the x-axis? Number 11. Where is this going to cross the x-axis? Good. Good. Where's it going to touch the y-axis? Good. Negative 36. Where is it going to face? Is it going to open up or open down? Up. Up, up, up. All right, you guys do number 12. Raise your hand when you got it. Cheater. What'd you get, Caleb? 3. No, that's... read to me the function. I want to know what the function... Here's a function in standard form. Tell me what that function would look like in intercept form. Read the whole thing to me.
Y equals x 3.
You don't like greatest common factors, do you? You factor these things out at the beginning and then you just forget about them. And they're long. Yeah. So what you should have done here is you factor out a 2, leaves you x squared minus 13x plus 30. And the two numbers that multiply to give you 30 and add up to negative 13, negative 3 and negative 10. But wait, if I put negative 10 first and then negative 3, that's fine. Just gotta make sure they're both negative. Jada, where are we gonna cross the x-axis? Good. Where are we going to cross the y-axis if you were to graph? 60. Good. Are we going to open up or down? Y up. What's positive? Now not the 60. Now not the x. A. This thing is positive. Alrighty. If you haven't worked on your homework assignment, start to working because I'm not gonna get the computers in here till Friday. It's gonna make for a bad weekend for you if you